So I know Jackson, George, you guys should have maybe, I think it might have been just Jackson and George and Nina. You guys should have gotten an email from me giving you the tape to the last class. Okay? So you might want to watch that. All right, so then the last four, number 7, I did as a permutation. Number 8, I did as a combination. 9, I did as an FCP. And 10, I did as an FCP.
Miss Linda, can we go over number 10?
Yeah. So 10. All right, so 10 is definitely a tricky one, right? So it doesn't say how many toppings you can choose, right? So you could make a pizza with no toppings, or 1 topping, or 2 toppings, or 3 toppings, all the way up to 15 toppings, right? And then we have 3 types of crusts, right? So what I thought in this one, I know we did one the other day, we did the ice cream one with either having whipped cream or not having whipped cream. So what I thought about in this one is I said, okay, we're gonna have 15 toppings. I lost my count. 15 toppings to choose from, right? And I said with those 15 toppings, we can either have the topping or not have the topping. So I did a 2 for all of those 15 toppings. There's 2 choices. You can either have it or not have it. And that tells you how many pizzas would be made with the toppings. Then I added 1 more line for the 3 options of crust. Ramses, does that sound okay for that one?
Yeah.
Because if you didn't do it that way, you'd have to say, okay, there is 1 type of pizza that I can have with no toppings. There would be 15 type of pizzas if I ordered only 1 topping. Then you'd have to figure out how many pizzas are for 2 toppings, 3 toppings, all the way to all toppings, and you'd have to add them all up and then multiply by 3. So I think thinking the toppings are our choices, you either have it or don't have it, I don't know, I think that's a little easier. Yeah, and I don't know if we did one like that on that recap. Okay?
Could you go over 9?
9, yeah. So number 9. So that one, Jenna, exact same thought, right? So if I have 10 different questions, both of them could either be true or false. So there's 2 options. So FCP, right? 2 to the 10th. Does that make sense?
Yeah.
So like on those, it doesn't say like I have 10 questions and I'm only choosing 4, right? It says on the 10 question true and false quiz, how many different answer keys are you? So there's 2 choices for each question, right? Any other ones that you guys want to go over? Okay, so we are going to do kind of the second part of this unit today, right, which is probability, okay? So we're still missing Mia and Yukiko, if anybody wants to give them a text, okay? Yeah, they might be missing, they might be excused, absent, I didn't look at it today, okay? All right, so we're going to do some things of probability. And there are some things on the calculator that I would normally do with you, but I checked the phone calculator and it doesn't have it on it. So I'm going to just kind of show you on my calculator but obviously you won't be responsible for that. I'm just opening my calculator up, so give me a second. All right, so I'm just, again, just to kind of show you some examples. Okay? So I'm thinking you might know some things about probability. Will, do you know anything about probability?
No, I don't know anything. Is that? Oh yeah, kind of.
What is
the
it?
probability of something to happen?
Yeah, it's the probability of something happening, right? So if you were to have a paper bag, right? Paper bag, and someone told you that there was a $20 bill, a $10 bill, a $5 bill, a $500 bill. And they said, you have the opportunity of winning $500 by just sticking your hand in the bag and pulling out one bill, and you get to keep that bill. What would be the probability that you get the $500? Right? You would say, okay, there is only one $500 bill out of 4 bills. So you would only have a 1 in 4 chance of getting that $500, right? So there's 2 types of probability, right? So there's definitely some things here with probability. Again, like I think everybody would have known it's the chances, like Will said, right? But then there are going to be some other things in probability that you're probably not going to know, right? So the 2 types, right? Empirical probability is the probability that will happen.
Miss Manila, we can't see your screen.
Okay, thank you. The probability that will happen when you actually perform the experiment, okay? So the probability that will happen when you perform an experiment. So usually I'll have a whole bunch of pennies, right? And we'll flip a coin, right? And we'll figure out what we actually get for the probability of heads, right? So I can simulate that on the calculator. So if I wanted to find the probability of heads, well, I would take the number of times, the number of times a head occurs divided by the number of flips, right? The number of flips. So I'm going to model that on the calculator. All right, so if I take my calculator, and I hope this version has it. Program, oh, it doesn't have it. My calculator at home had it. So let me look apps. Might be in here. There we go. There it is. Probability simulation, right? So I can either toss coins, roll dice, pick marbles, spin a spinner, draw cards. So we're just going to toss a coin. Whoops. Okay, so I can hit enter, and I'm going to see the probability of heads. Right? Toss. Toss. Why isn't it tossing? Let's see if I hit this. There we go. It tossed it once, and I got 1 head. It tossed it twice. It got a head and a tail. I'm going to go and toss it 50 more times. Right? So if I toss it a total of 52 times, you can see that it came up tails a couple of more times than heads, right? If I do another 50 times, right? 60, again, a little more tails. If I keep on going, what should, after I keep on going, larger and larger and larger, I'm trying to get it, we're almost there, right? It should be really close to 50%, right? The bars should be pretty equal. So you see, as I'm doing more and more, right, they're still close, but they're not exactly 50%, but that's what theoretical probability is, right? Theoretical probability is the probability that should happen after an infinite number of trials. Infinite number of trials. Right? So let's say I did that flipping of a coin and I had 272 out of 500 heads. Right? So if I do that as a decimal, it'd be about 54.4%. Theoretically, it should be close to 50% because on a coin, there's one head out of two sides. So through your homework, these words are going to be used, right? Empirically is actually what happens. Theoretically is what should happen over a large number of trials. Okay, large number of trials. Any questions on those two different types of probability? Again, I kind of like doing these sections at the end, the counting the probability, because again, you sometimes have some knowledge of it, and it's not that bad. While I'm thinking of that, we're not going to have tons of assessments, guys, in this next month, right? I think right now I'm only planning 2. So we're doing practice assessments beforehand. Please make sure you guys are staying current with stuff because you don't want to get yourself in a, bad situation with not many assessments. Okay? Okay. So that's what we were going to do on the calculator that I already did. Okay? So now some other words, right, that you need to know. Sample space. Sample space are all the possible outcomes that can happen in an experiment. So for our flip of the coins, the sample space, right, the sample space would be our 2 options, heads and tails, right? That would be our 2 options. A subset of the sample space is called an event, and that would be something like, I'm looking for heads, right? That would be an event. So the sample space is everything that's possible. An event is we're going to pick one of those, and we're going to find the probability. Okay? So we talked about that tree diagram the other day. And a tree diagram helps with probability as well. Right? So let's say we have a 4-question quiz. Right? Well, actually, let's only do 2 right now. Let's only do 2. We'll start off small. A 2-question quiz. And the answers can only be true or false. Right? True or false. So I want you to write, we're going to do it together, right? I want us to write the sample space. Okay? So we need to write this in an ordered fashion. So the first question could either have an answer of a true or a false. Right? A true or a false. The second question, it doesn't matter what the first question was. The second question could also be a true or a false. If it's false, it could also be a true and a false. So I'm going to follow the tree. One piece of the sample space could be a true and then a true. A second piece of the sample space could be a true and a false. Third piece of the sample space would be a false and a true. Last piece of the sample space would be a false and a false. Do you think any of those pieces could be considered similar pieces in the sample space? I don't want to say the word same, because they're not exactly the same, but I do think there's two similar ones. Why do you think, how can I reword these middle two to kind of call them the same piece? How are those two middle ones similar? Right, so Michael's saying they're just flipped, right? Where that would be order important, order not important. Right, so I kind of look at the first piece as being 2 truths and 0 falses. I look at the second and third piece being 1 true and 1 false. I look at the last one as being 0 truths and 2 falses. Right? So the probability of getting them both to be true would be 1 out of 4 options. The probability of getting them both false would also be 1 out of 4 options. The probability of getting 1 out of each, would be 2 false. So you would be more likely to get a quiz that had 1 true and 1 false on the quiz. Okay? So what I want you to do is I want you to write one up for 3 questions. Alright? So I don't know if it's on my next slide or I need a blank slide. Nope, I need a blank slide. Okay? So I want us to write one for a 3-question quiz. Okay? So you're going to have the first question, the second question, the third question. Alright? If you think about it, we could have 3 questions that are true and 0 false. We could have 2 questions that are true, 1 being false. We could have 1 true question, 2 false questions. We could have 0 true and 3 false. So what I want you guys to do is I want you to build a tree just like what we just did for 3 questions. Then I want you to find the probability of each case based upon the sample space that you get. Right? So I want you to find the probability. So try to draw the tree, right? So all you're going to do is take this tree that we just did, and you're going to extend it 1 more piece, right? 1 more piece. That's what you have to do. And then you're going to write out all the possibilities. So like the first one, I would get would be a TTT, all truths. Right? So try to extend it 1 more branch, I guess. when we kind of talked about the tree the other day, right? It's an ordered way to list all the possibilities. So if I list them from my tree, right, you don't have to do it this way. You could just kind of go and try to write all the possibilities, but I end up always forgetting one. So I like doing a tree because it's an ordered way to write them. Whoops, did I write the last one wrong? No. Right? It's an ordered way to write them. Alright, so now we're going to do probability. Jackson, how many of those options are all true? Jackson, are you there? Say again? I got 8 of them. Yeah, you got 8 too. 1, 2, 3, 4, 5, 6, 7, 8. You just didn't write them. Yeah. Ethan, how many all true?
I had 3.
3 with all T's? With like all 3 of them being a T?
Oh, no, only 1, sorry.
Yeah.
I thought it was the majority.
Yeah, only 1 out of 8 of them, right? 1 out of 8 of them, because I got a total of 8, right? I got a total of 8. I'm going to go to the bottom one. Jack, how many of them had all falses? Jack, are you there?
Is it 6?
I don't think 6 of them had all F's. How many of these 8 pieces in the sample space were all F's?
Oh, just one of them.
Just one of them, right? So again, it's weird I'm asking those questions, right? Sophie, how many had 2 trues and 1 false?
Was it 2?
I think there's more than 2. Look again. 2 trues and 1 false.
Oh, there's 4. Okay.
I don't think there's 4. Aren't there 3?
Yeah, that's the 3rd.
Yeah, if you check them off as you go, right? So here's 1, 2, 3, right? So 3 eighths, and then if you count up the ones that are left over, that's 3 eighths, right? So the likelihood of you getting a quiz that had 2 trues and a false, or one true and 2 falses are the same, right? So again, it's the likelihood of these questions happening. So it's not very likely that all of your answers would be true. Okay? So how's that for the words, right? Are you okay with the difference between empirical, theoretical? Are you okay with the difference between sample space and event, right? So in this problem, right, this is my entire sample space, right? This is my entire sample space. One of these is an event that happens, and this is the probability of the event. Okay? I'm going to ask you a question off of these for our next one. What's the probability that all of the answers are the letter B? In that true and false question, what's the probability that all the answers come out to be B? Actually, let me even use something better. Let me use C. And there's a reason I'm choosing C. Are any of those T's and F's C? Right?
What do you mean C?
I mean the letter C, Jenna. I know it's weird, right? So are any of these letters right here that I'm pointing to, Jenna, C?
I still don't know what you mean by C.
I just mean the letter C. Are any of these letters right here the letter C?
No.
No. So there are 0 out of 8 possibilities. So this is an impossible situation, right? So that's what I'm trying to get out of you. I'm trying to get what's the probability of something that's never going to happen, right? Am I ever going to use the letter C for a true or a false? No, that's why Jenna was so like, what are you talking about? It doesn't make sense, right? Same question, same idea. What's the probability that the answers will either be a T or an F? Aren't all your answers either a T or an F in those situations, right? So that would be an 8 out of 8. That's called a sure event. Something that will always happen. Okay? Is that okay, Jenna? Right? That's what I was trying to get out of you. That impossible things and sure things happening. Does that make sense now that you know where I was trying to go to?
Yeah.
Okay. So that's going to be kind of our next statement. All probabilities have to fall between 0 and 1. 0 is an impossible event. 1 is a sure event. So an impossible event. Another example, Halloween falling on January 2nd, right? Our Halloween will never fall on January 2nd. So that's an impossible event, okay? Halloween falling on October 31st is a sure event. That is always going to happen for our Halloween. Okay? So sure events and impossible events. So when you're given answers to probabilities, right, the answer of the probability always has to be between 0 and 1. So you could write in inequality. You can represent that as a fraction, like 1/4, or a decimal, like 0.25, or like a percent, 25%. Okay, so there's 3 different ways that you could write your answers. All right. Either way is okay, right? So Michael asking here, is any way okay? Any way is okay. The only thing with a fraction, it needs to be a simplified fraction, right? So I couldn't do 2/10. I'd have to simplify and go 1/5. So it's just going to be simplified. All right, so let's do some probability problems. Now we're going to get into some different scenarios. All right? So I have a bowl of M&Ms. There's plain M&Ms and peanut M&Ms. Okay? So I have the total of red, blue, green, yellow, orange. Right? I think I did 50 of each of them. All right? So there's a total of 100 M&Ms. So now I did this so that I would show you each type of probability. So I have 3 different types of probability here. The first 2, A and B, regular old probability. I'm going to look at how many blue M&Ms I have over the total of the M&Ms. Right? So that's what I'm going to look at. How many blue? So I'm going to look at my chart. In blue, I have 29 out of all the M&Ms, 100. So I look at that and I say, okay, can I reduce it? Nope. So that's a good enough answer. All right, so you guys think in your head, what is red gonna be? Right? What's gonna be the probability of a red M&M? Red M&M.
18/100.
Good. So Jenna's saying 18/100. Wolfgang, can I simplify that though? Can I simplify 18/100? Wolfgang, are you there? Michael, how about you? Can I simplify 18/100? Sophie, can I simplify 18/100?
There's the other Michael.
Say it again.
Are you talking to me or the other Michael?
I was talking to you, Michael, but that's okay. So, Michael, you, can I simplify that? Thank you.
Yeah, it could be 9/50.
Good, yep, 9/50. So, the benefit of going and doing a decimal is that you don't need to worry about it being simplified. Okay? All right, the second one. The second one, right? Any questions on those two guys? The second one is an or, right? And it says yellow or plain. So you got to be careful on this one. There are 18 yellow ones and there are 50 plain ones. Why isn't your answer 68/100, and then if I simplify it, 17/25? Why is that not your answer? There are 18 yellow, there are 50 plain. What's wrong with what I did?
12 of the yellow are also plain.
Awesome, Matthew, right? So 12 was double counted. So with an or problem, you need to find the probability of the first one, add the probability of the second one, and subtract out the probability of their overlap, right? So if I really did this, I should go yellow plus plain minus the overlap together. That's like the real way to do an or problem. An or problem. Honestly, I don't do that. I kind of say, okay, there's 50 plain. So I did the 10, I did the 13, I did the 7, I did the 12, I did the 8. And then I go ahead and add in the yellows I didn't count yet. I add the 6. So either way is fine. Okay? So these two problems, C and D, right? D is trying to model something that is considered, another vocab word, mutually exclusive, right? They're separate from each other. The red and orange don't happen together. So there's no overlap if I'm asking for red and orange. So letter C would not be mutually exclusive. Letter D would be mutually exclusive. There is no overlap. So I don't need to do the subtract out. Okay, are those two okay? And again, this is all common sense type stuff, right? There's going to be one on the next slide that's a little different. So then the last two, right, are our sure event. It's either plain or peanut. Our impossible event, no black M&Ms in our bowl. So you have really 4 different types of probability here. A and B, regular old probability, right? C and D are your or problems, mutually exclusive. E is your sure event, and F is your impossible event. Any questions on those? probability. So I don't know if you guys are going to know how to do this one, right? So I just want you to read the first one. It says a blue candy, then it has this vertical line. And this vertical line right here means given or knowing that it is. So what A says, it says what's the probability of a blue candy knowing it is a peanut M&M? Right? A blue candy knowing that it's a peanut M&M. So there's a formula up there, right? But I don't really want you to worry about the formula. Ramses, give me an answer. What do you think? A blue candy knowing that it's a peanut M&M. What do you think? Random guess.
I would say 25.
Well, it's gotta be a probability, so it has to be a fraction. And I don't know where 25 is coming from because I actually don't have a 25 anywhere on here.
Okay.
So
well, you said, so I was like, oh, okay, let's do random.
that's really random, right? But I want it to be educated random, right? So a blue candy knowing that it's a peanut M&M.
That'll be 16 over 100, so then that'll be 0.16.
So close, so close. You said 16 over 100. You are really, really close. Does anybody want to try another guess? Again, a blue candy, knowing that it's a peanut M&M. So I'm going to think Ramses picked 16 because that's how many blue peanut M&Ms there are, right? But how many just peanut M&Ms? 50 just peanut M&Ms. So what you do in these problems, right? So the answer would be 16 out of 50, or if I simplify that, 8 out of 25. So what you do is you say, okay, I'm going to forget about all the plain M&Ms, and I am just going to concentrate on the peanut M&Ms. So whatever comes second, that's the given part, and that's what you're going to concentrate on, right? So I'm just concentrating on the peanut M&Ms. And I'm going to say, okay, how many of those are blue? 16 out of 50. Okay, 16 out of 50. Is that okay? Ramsey, is the 50 denominator okay rather than the 100?
Yes, ma'am.
Okay. All right, so you guys try B. Red, knowing that it's plain. Red, knowing that it's plain. Michael here, what do you think? Red, knowing that it's a plain M&M. So how many plain M&Ms are there? 50 plain M&Ms. How many of those are red? 10. So 1/5. Okay. Is that okay for B on everybody?
Yes.
Yeah.
All right, good. Let's try C then. C's going the other way. I know it's blue, right? I know it's blue. What's the probability that it's a peanut blue? I know it's blue. What's the probability that it's a peanut blue? Somebody give me the answer. Tell me what you think.
Would that be 16 over 29?
Awesome, Ramses. Yep, 16 out of 29. So you know it's blue, so you're only looking at the blue ones, and then 16 out of 29. Good. Okay? Is that okay? So it's always the second word that reduces the number that you're looking at. Okay? All right, so this is called conditional probability, right? So last page was our regular probability, our or, our sure and impossible. That one is called conditional. Okay, we got one more type that's got two parts. Any questions on any of these? Again, I've been calling on a lot of people and they're not responding. I know Michael had his mic on, totally fine, right? But I'm questioning who we have really there. So make sure you guys are paying attention to these. All right, so this is our last type that we're going to do today. I think this is our last type. Yep, this is our last type we're doing today. Okay? So this is when you choose more than one M&M, right? So our last problems were an or. These problems are an and. All right? Okay, so Michael's saying, do you add it together? Really close, right? I was going to say, you treat it like stages in an FCP, right? So your first stage on this first one is going to be, I'm going to find the probability of getting a blue M&M. And then the second stage, I'm going to treat it, right? Or I'm going to look how much it is for a red M&M. So Michael, instead of adding, what do you think we do? What do we do with the stages in the FCP? You multiply them. So all you have to do is multiply them together. So I still like to draw those little lines as stages so that I can fill in some answers, right? So this first one is going to be without replacement. So you pick an M&M and then you eat it. You do not put it back in the bowl, right? So the probability that it would be blue would be 29 out of 100. All right, so you assume you got a blue. You assume you got what you wanted. You eat it. 99 M&Ms left. Now I'm going to say the probability of red, 18. Okay? So each stage you do separately. You are going to look at whether it's a with or without replacement. So this one, I tend to always do decimals for these just because it's easier to kind of multiply them out. So if you want to check in your calculator, I'm getting 0.053. Okay, so Michael's asking on the next one, right? It's the same exact problem, but I'm doing with replacement, right? So there's 29 out of 100, right? I look at it, I get a blue, but then I put it back in the bowl. So how many are in the bowl? Not 50, but is it there a total of 100 still, right? So it's still 100, 18 out of 100. So the only difference is that you put it back in the bowl. Okay? So
What does, sorry,
that's okay. It's going to differ by a little bit. Go ahead.
what does B and R mean again?
B and R?
Yeah.
Oh, blue and red.
Oh.
Yeah, sorry, blue and red. So are those two okay? Are those two okay? All right, so try C. First, I want a green M&M. That wants to be my first one. My second one, you want as an orange M&M. The third one, I want as a red M&M. All right, so try that one, please. Without replacement. We're not putting it back in the bowl. We're eating it. Anybody get an answer at home? Two decimal places, three decimal places. Yeah, you probably want three decimal places in this one. Because I'm getting my first two decimals at 0, 0. Yeah. So Michael got 0.00556, right? So if you round it off to three decimal places, you probably round it off to 0.006. Does anybody want to see the work for that?
Yeah, I don't really understand that much.
Okay. So Jenna, how many green M&Ms are there?
20.
20 out of 100, right? So now I pick one M&M, it's green, I eat it. My next one I want is orange. So how many orange?
15.
Out of how many are left over after you ate one?
99.
Yeah? So then what's my last fraction for red? I eat the orange one, how many red out of the total?
18 over 98.
Yep, that's it. Multiply your numerators, multiply your denominators, and divide it. 0.006.
So you just multiply the top and then multiply the bottom and then divide them both.
Yeah. So 20 times 15 times 18 is 5,400. 100 times 98 times 99 is 970,200. And then you just divide them and you get 0.006.
Okay, thank you.
Yeah? Alright, so only difference between the last one is that they're both the same, right? So it'd be 29 out of 100. I eat a blue one. I don't have 29 blues anymore. I only have 28. Okay? So we have to reduce that numerator when they are repeated. So I'm getting, when I multiply that, 0.082. Okay? So the things that you have to pay attention to, right? Things that you have to pay attention to. Is the problem asking for an empirical probability versus theoretical? So like empirical is the experiment had this, right? That would be empirical. Theoretical would be what would happen if, right? If you do this. So then sample space, that's when you're going to list them all in an ordered fashion. Okay? Sample space are one of the, event are one of those pieces. All of our probabilities can be a fraction, a decimal, or a percent. I don't care which way you answer it. They all have to fall between 0 and 1. And then we did all the different types. So A and B were your basic. C and D, you don't want that overlap, right? And then our last, one more conditional, right? So that's when the denominator gets reduced. And then our last type is when we're picking more than 1. Okay? So we have to do, but we're going to do it next time, right? Letter C, we have to kind of go, if I make a letter E, I have to go, what's the probability of a green, an orange, and a red in any order, right? So I'm pretty sure that I'm giving you one of those for homework, right? I'm just looking at Michael that I gave them to see if it's there. Oh, maybe I did it. No, I didn't, right? So that's what we're going to have to start with next time, because that's going to bring in our FCPs and our probabilities together, right? Then we're going to do our complement problem. And I haven't decided if we're going to do binomial yet, but we are going to do expected value. So we will only have kind of one more day on this. Then we're going to recap. Then we're going to have a quiz, okay? So if you look at your homework on Canvas, okay, homework on Canvas, I put the same document in here twice, right? So probability day 1, right? It says only do number 1 to 18. Okay, so that's going to be our first probability homework. So first one, I'm giving you what happens when rolling a die, and empirically, you're going to figure out the probability. So these are 5 different problems, right? So it's not like picking which letter. It's saying, okay, I rolled it 20 times. The probability of rolling a 1 would be 4 out of 20, or a fifth, right? So you're doing A through E on number 1 and 2. So theoretically, what it should be, on a die, there's one side out of 6s that have a 1, right? So that's how you're going to answer those A to B, right? So you've got some OR problems in there. You've got a different event happening, right? So I tried to give you an empirical and theoretical one, right? And then I'm asking you, should those answers be the same, right? So I want you to think about that, right? Maybe some of them will be the same. That's your sure and your impossible, number 4 and 5. Then number 6, we actually have the picture in your notes already, right? So then sample space, right? And then what's the probability? And then our last one is taking our M&M problems and putting them together, right? So you've got the 9 and 10 individual probability, then you've got 11, 12, 13, 14, the ORs, 15 as well. Then you've got some given ones, okay? Actually, I didn't put any and ones in there, okay? The and ones, I guess we could do the and ones too, but that's okay. No, up to number 18 is fine, okay? So that's what you guys have to upload for next class. Do we see each other Monday? I don't know. Monday starts with period C. Yeah, so we don't see each other Monday. So this is due for Wednesday. Okay, Wednesday 1 to 18 is due. Okay, so if you guys are still there and you don't have any questions for me, right, go ahead, log off, work on this stuff, right? You got about 15 minutes. Or if you need to get somewhere, just kind of put it off to the side and you can do it before Wednesday. Okay? If you want to stay and do it, you can stay and do it. Okay?
Thank you.
Have a nice weekend, guys.
You too.
Thank you.
Bye.
Thank you, Miss Mendel.
Bye, guys.